To now look at probability axioms. So we're going to look at the three probability axioms, but before that, let's just quickly look at what do we mean by axioms. Let's just quickly look at what do we mean by axioms. Now, axioms give you basic rules. Now they give you basic rules on which rest of the concepts are based. So they're giving us basic rules on which you're going to base the rest of the concepts are based. So you believe them as it is. We don't question the validity, right? So you believe them as it is. We don't question the validity. You believe them as it is. You don't question their validity. So these are axioms, right? So axioms are what we believe as is. We don't question the validity. We're going to believe them without any proof or anything. We're going to not question the validity. You don't question their. Everything else builds on these. So this is what we mean by axioms. So when we're going to look at three probability axioms, so this is what's going to form the basis of the rest of the probability theory. We're going to believe them as is. We won't question the validity. So now let S denote the sample space. And A and B are two events in S. And let A and B be two events in S. We look at three basic axioms on the basis of which the rest of the concepts are based. The first is going to be the probability of A, which is an event in the sample space, is greater than equal to 0, less than equal to 1. That's the first axiom. Right, so 0 probability means event never happens. And 1 is event is certain to happen. So this is the first axiom that we looked at. Okay, the probability of any event is greater than equal to 0 and less than equal to 1. So all probabilities are going to be between 0 and 1. The second axiom is the probability of the sample space is 1, where S is the sample space, right? S is the sample space. So probability of the sample space is 1 because the idea is that when a random experiment is carried out, something has to happen, right? When you do a random experiment, something has to happen, right? Something will happen. You will get one outcome. Something has to happen, and whatever is happening happens from the sample space. Right, so the probability of sample space is 1 because whenever you perform a random experiment, you get exactly one outcome, and that outcome comes from the sample space. So the probability of the sample space is 1. Now, the last axiom is that if A intersection B is equal to the null set, they're mutually exclusive errands. Then probability of A union B is probability of A plus probability of B. If, and again here the key condition is they're mutually exclusive events. Then the probability of their union is equal to sum of their individual probabilities. Here it's important to me keep in mind can be more than two events. So these can be more than two events. You can have more than, you can be looking at the union of more than two events. For example, you could have probability E1 union E2 union E3, so on and on. So this could be like you could be looking at the union of n events. If they're all mutually exclusive, then their probability union is also the sum of their individual probabilities, right? So this applies in general. This is not just for two events. You could have any number of events. If they're all mutually exclusive, the probability of the union is the sum of the individual probabilities. The only condition is if all the events are mutually exclusive. So as long as all the events are mutually exclusive, the probability of the union is the sum of the individual probabilities. Events are mutually exclusive. So these are the three probability axioms.